Hello everyone and welcome to the Game Engine programming series where I write a game engine from scratch. I'm certainly glad that you could join me today because we are going to write some easy and fun code in this video. The code will not be a brain teaser but necessary nevertheless because we still have to check whether the code that we wrote in the last two videos is actually working correctly. Therefore, I'm going to write a test program which will also be the base for any other tests for the engine that we might be writing in the future. Also today, I'll write the DLL so we can expose the functions of engine library to the editor. And I'll also write code to import those functions and use them in the editor. And so we will have the very first interaction between the editor and the game engine. In other words, today we'll officially be using the game engine, which is rather exciting. I can't wait to do all this, so let's get coding. To write a test program, we'll need another C++ project that I'm going to add now. I'll use an empty project for this. So it's a C++ console or Windows empty project. Again, I have these filters that I don't need, so I remove them. And the first thing I'll add is the main CPP file. And here I'll just add the entry function, which is main. And in this function, I'll just call my test routines to test whatever part of the engine I want to test. So for that, I need an interface for all the tests that I'll be writing. And that's something like this. This is an abstract class from which all my tests will inherit. And then I'll just put this in its own header file so I can include it to each test file that I'll be writing. Now imagine I have a class that inherits from this test class. Then in main function, I could just call these three methods member functions that I defined here to initialize, run, and shut down the test. Of course, it gives me an error because I haven't implemented the interface. So for the sake of this example, I'll just make a couple of empty member functions for this class. Now in the main function, I can just call these methods. So if the initialization succeeds, I can run the test. Of course, I need to make these public. And after I'm done with the test, I just shut down this test so it can clean up anything that it needs to clean up before exiting the program. Now, for example, I can have a couple of defines here that would enable or disable certain tests. Today we are going to test the entity and component functionality of the engine. Therefore, I'm going to define macro that is just for enabling that particular test. So here I enabled this particular test that is about the testing of entity and components. And after this, we can put any other tests that we write in the future. And if none of those are enabled, then we will get a compile error because, well, we have to have a test to run in the main function. And one other thing that I want to do is to put this in its own file. So we just include those files that we need for each test. So in this file, I'll include the test. What I want to do here is to test functions from the engine, and those are in a namespace, the primal namespace. So I'm going to just do a using namespace. Normally, I don't do something like this in a header file because, well, then it will be propagated through every CPP file in which we include this header. So that's not a good practice to do this, but this is a test project made specifically for the engine. So it's okay to get rid of this primal namespace everywhere. And because I'm going to use these headers from the engine, I'll need an additional include path in the project. So I'll add that here. For all configurations, I'll have an additional path to include directory to this common header files, to this common folder. And I'll be also using the library itself to link to. So I'll also have additional library directory. But the library itself is in the output directory. So I'll just use another macro, that's the out directory. And that's basically it. Now here I can just include the headers for the entity and transform because those contain the functions that I'm going to test. And here in the main, I need to include this header. And also tell the compiler which library it needs to use, right? Okay, right now we should be able to compile and build this project. Let's see if that is okay. Right, it tells us that the namespaces that are nested, well, if we want to use a namespace like this, then we at least need C++17 because that's the feature that is introduced in C++17 and later. So I'll have to set the language for this project to C++17 as well. And it worked. There are a couple of more things I would like to do here before we start writing the test. First, I'll just check for any memory leaks that might happen if we do things in the engine. So we will catch those here during our tests. And one way of doing that in the debug build is a C runtime function that we could set to detect those leaks. There are a lot of flags that we could set to detect different kinds of memory leaks. The ones I'm going to use for now are this one. And we can R those flags together. So these are the flags that I set. And what these exactly do, well, we can just Google the documentation and see what this function actually can do for us. So there is in this Microsoft documentation, and here are the descriptions of each of those flags that we can set. And there are a lot of tests that we can do to detect a lot of memory defects that we can have in a program. And well, the ones that I was using is just the allocation memory DF, and that's this. Every time we allocate space from the heap, then we also have to release it, and that's what it checks. And the other one is leak check. Oh, this one is just for error report. So if we have any leaks, then it will dump what it was leaked in the memory in the output of Visual Studio. So now, for example, I can simulate this by allocating memory here and then not releasing it. So now I'm allocating space for 4 floating point values, and then I can run this program and see what happens. Here you can see that it says, okay, there is at this location 16 bytes that we leaked, and well, that's correct because each floating point value is 4 bytes long, and 4 of them are a total of 16 bytes. So that's correct. So we can detect all the memory leaks in the engine. And further, I am done here in the main, so we don't really have to do anything except, well, of course, put this in its right place. So for example, if we have any other tests that we want to do, we can just disable this, and then it will pick any other test that would be enabled. But right now we just have one, and it goes to this error because, well, now we don't have any tests that we can do. So the way I want to test this addition and removal of entities in the engine is to just add a random number of entities to the engine and then remove a random number of entities from the engine, and repeat that a couple of times and see if anything goes wrong. If I can check whether all the numbers are sane, so, well, we can check if then anything weird is going on. So here I have included these two C++ headers. The first one is for me to be able to output messages to the output window with the cout, like so. And without this header, we won't be able to do that. I need seed time to generate a new seed for every time we run this program. So there is a function, the C function, that's this random seed. If you're familiar with how pseudo random numbers work, then you know that every time we run a program and it uses the same seed, then it will generate the exact sequence of random numbers every time. So without this line, the first number we might get is maybe 3, and the second one that we ask for is 5, 8, and maybe 2, and so on. And every time we run this program, we will get the same sequence of random numbers, which might not be what we want. So using this, we can have a seed, so it starts somewhere else in their sequence. So the second time we run this program with another seed, then it would produce a different sequence of random numbers. And that's what I want for this test to happen. And other than that, we don't need any other initialization for this to happen. So I just return true. And the same is for shutdown. I don't have to free up anything here for this test. So the shutdown method is empty. I am going to create entities and remove entities, so I need a list of entities that I have during this test. And I'll just remember how many entities I added during the test in total and how many entities were removed. And at any given time, how many entities I have, which is just the size of this array, right? So here I'm going to run this test until the user presses Q, for example, to exit the test. And then I'm going to randomly add and remove entities. So here I'll have two functions that create a random number of entities and remove a random number of entities. And then I'll just remember how many entities I have at this moment. Now I can go ahead and implement these two methods. And here what I want to do is to add maybe somewhere between 0 and 20 entities to our engine and then see what happens. So this random function gives me, I think it gives me a number between 0 and I'm not sure what the upper bound of the numbers are. Not that it really matters, but we can check. Okay, it's between 0 and random maximum, which is 32,767. So every time I want to have like a random number between 0 and 20, I can just use this modulo to select those. But I also want a minimum of 1,000 entities in the engine, so I can have a bit more realistic amount of entities in there to test. Actually, I just want to add like 1,000 entities in the first go. So if this entity is empty, entity list, like this, I just add 1,000 entities. And for those entities, I need a transform component. So I need to fill in that init information. but I just use its default value. So this, if you remember, this is just the position, zeros, and rotation will be zeros, and scale is 1. And then I'll have a game entity info, which I'll fill in with this transform info. Of course, I need to give it a name. So now we have an entity information that we can use to call the create entity method. Now we are adding an entity, so the added will be incremented. And one of my conventions in the classes is that I add an underscore to any member variable that we have. So let's do that now as well. And now I can call create entity method. This is it. In this method, I create anything between 0 and 20 entities, except when the number of entities that I already have is less than 1,000, and I just add the first 1,000 entities in one go. And then after that, I just add this number of entities here. And then I check if the entity that was returned is valid, and add it to the array of entities that I have. For remove random, it's the other way around, basically. The first thing I need to do is to determine where I need to remove an entity, right? Because I have a random number of entities that I want to remove, but I don't know yet where I want to remove entities. So here we can see that I have at least 1,000 entities. There might be more entities, and so I'm using the total size of the array of entities to determine a random number in that range between the index of 0, which is the first element, first item in these entities array, and the last one. One of those will be removed. And the way I determine that is to just use the random function again for this number of entities, and it will give me a number between 0 and the number of entities. So here I determined where I want to remove an entity, and then I have a reference to that entity in the array, and I can check or assert whether this is valid in 2 different ways. So I can check more functions that I wrote. And if that's the case, I can try and remove the entity from the array of entities and also from the engine. And one more thing I could do, I guess, is just to assert if this entity is not alive anymore. And here it should be alive. And finally, I need a method to output the results to the output window. Okay, I think this is the entire test for now. And let me see, maybe I should also explain this. So I create and remove entities in batches of 10,000. And that's because I also want to have an error whenever our generation in this ID wraps around. So if you remember, we had this assertion that this generation should be less than the maximum value for the generation that fits in this number of bits. So if that happens, then that could be a potential bug in the game if that happens. So here in the tests, we can see when that happens. So now I can run this program. It's for some reason taking a long time to run. So let's see what's going on. I'll just step through the code and see what happens. Okay, so if we are correct, we just added 1,000 entities and that didn't happen. Let's try again. Oh, of course, I made a mistake here. It should be bigger than 0. So we can see right now that this works. It's saying that we should remove an entity at position 806. And we have 1,000 entities. And this one is also number 806. So that looks good. So I can here add a watch for transforms at index 806. And then we can see probably that, yeah, this is an invalid value for an ID. So that means that this entity is dead. That's good. And then the next thing is to go here. Oh, I forgot to print the results, of course. That's why we don't see anything happening. I'm not sure why it says that no entity was deleted. That is because we don't set this value. So here, when we remove an entity, I also need to increment removed entities. In the first round, it added 96,000 and it removed 94,000. So we have now about 2,000 entities left. Now every time I hit enter, this number goes up because the total number of entities that we added and removed just increases. And at some point, this generation thing is going to wrap around and then we'll get an assertion error. Like this. So here it says that, well, there's a debug error. So if I press retry, then we see that it stopped here and generation is indeed 255. That means that after almost 1 million additions and removals, this generation has wrapped around. So it's the decision of the game programmer or the game engine programmer, if this is an acceptable risk to take. Because if you have like around 1,000 entities and you added and removed 2 million in total, and you have somewhere an old ID hanging around and you ask for that entity, then you would get the wrong entity. So the chances of that happening is, of course, minimal, but still it can happen. So one thing you can do is to set this number of bits a bit higher, so this happens later. And if you think this is totally acceptable, you could also set this lower. So while we are stopped here, we can go in the call stack and check what our other values are. So one thing I wanted to see is if the number of added and removed adds up together to the number of entities that we have now. So here, if I bring up the calculator, I can have 993,153 minus the number that was removed, 988,230. And we are left with 4,923 entities. And that's not quite this because we were in the process of adding the last patch of entities and we stopped before updating the number of entities. So that's why it isn't quite the same number. If we want to know for sure, then I can check this. And it's 12. So 23 minus, let me see how, yeah, well, I can't really know how much it was initially because we decrement this every time. So, well, if you really want to know, you have to add another variable here to just remember what the initial value of count was. And then you can do this bookkeeping if it really is correct. But I trust that it is for now. And I can even go further and create game entity and see if these are okay. So there is like 6,671 entities in here, which is not the 4,000 that we saw earlier. And that's because we have a lot of free IDs here. So in this array of transform, there are a lot of holes. So if we now subtract these numbers from each other, like this is 6675 minus 1748, then we get that same number that we have here. Yeah, when subtracting removed and added, then we also got this number. So that's correct. And well, now our test is kind of interrupted because of this assertion fail. So one thing I can try is to indeed increase the number of generation bits and see if that increases the number of times that we can add and remove entities. So I made it 10 bits instead of 8 bits. And that means that we now have 1024 maximum value for generations. So as we can see, we are already in 1.5 million entities, and it's going on pretty well. And I predict, because we can now put 4 times the number of generations in there as we could before, that this will also terminate at around 4 million, 5 million maybe. Okay, it went on for a longer time than I thought it would, but yeah, well, at 8 million additions and removals, it will wrap around. So that's the difference. But it also depends on your random distribution and those kind of things. If you add and remove the same entity basically all the time, then of course it will wrap around quicker. So yeah, that was the test. I think we could do a lot of more tests here, but for now I think this is quite representative of the functionality of the code that we wrote earlier. And also now we have a base for other kinds of tests that we might want to write later on. And yeah, I think I'm happy with this, and I want to continue with the DLL for exposing the functions from the engine library to the editor. So this time I'm going to add a DLL project. A Windows Dynamic Link library would be nice. Here it is. So here we see that it created a default entry function for the DLL. And well, I don't really need this for the intended purpose of this DLL. And now the only thing I want to do is actually to also check for memory leaks here. And that I can do whenever this DLL process is attached to any other process. So the only thing I have to do is to copy paste these 3 lines from our test to the DLL main, and we are done. I also need to get rid of this precompiled header. I'll rename this DLL main. It actually created more files than we care to use, so I'm going to delete all these files and delete these filters as well. Now in the properties, I also need to tell the project that it shouldn't use precompiled headers. And here also I'm going to link to the engine library, so I need to set an additional library directory. And now also because I removed all those files, it doesn't know that it should include these from the Windows header. So I'm going to include the Windows header again. And this project is used exclusively with the editor, which is also a Windows application. So it doesn't really matter that we now include the Windows header in a global place. So this also gets rid of some less frequently used Windows headers. So the compilation would take little less time. And it also doesn't recognize this CRT function anymore. So I'm going to have to include the CRT debug header. And that takes care of it. Let's see if it compiles. All right. Okay, now I am ready to expose the engine API to the editor. So therefore, I'm going to add a new CPP file. So here, I want to export any function that I want to use in the editor. The way to do that is to define a macro. What this does is whenever we put this in front of a function, for example, something like this, it will export this function from the DLL. And that means that it uses this name literally. That is what this extern C means. Because C++ compiler normally does some addition to any function's name. And that's, I believe it's called name jumbling or something like that, if I remember correctly. Name mangling. All right. So yeah, the compiler will add these kind of at and then numbers and everything. And it's according to some scheme or other, but the thing is that if we want to refer to these functions from outside the DLL, we of course don't know the mangled name of the function. So we need however it was declared here in this CPP file. And that's what this extend C is for. And this part is self-explanatory. It means that, well, this function is exported to the outside world. To anyone who imports or loads this DLL will be able to use this function. Now here, again, because we are using this library, this engine library, I'll have to tell it that it should use that one. And again, we need an additional include folder as well. So now here I can include the common header and entity and transform headers. Again, we are using namespace primal, so I don't have to type that in every time. And then I just want to expose these two functions that we can use to create and remove entities. Here, I want to have a function that calls this and one that calls the remove game entity. So this one returns an ID. Okay, again, I'll need to use the right language version. Now I'm returning an ID type, which is just a U32 basically, instead of a complete entity, because in the editor, if we remember how we constructed the entities, in a game entity, we have our own class for representing an entity in the editor. So what I basically want to do is just to have an integer that remembers what the ID is of the entity that is in the engine. So what I want to do is just doing something like, and then have another property that activates and deactivates the game entity, and that means that we need to add an entity to the engine or remove it from the engine. I'll actually rename this to entity ID. And the default value for it is ID basically -1, but I still have to add a little utility here to handle those IDs in the editor as well. It's not so much work, so I can do it right now. Here in utilities, I can add another static class. So here is a constant value for an invalid ID, which is -1, and a method that can check if the ID is invalid or not. If we want really to do it properly, then we also have to have something that is as big as our ID type, because right now our ID type is 4 bytes, and an integer in C# is also 4 bytes. But if we would change this to 8 bytes, so U64, for example, or to 2 bytes, then in case of U64, then it wouldn't fit here in anymore, and then we would have a bug. But for now, I'm just going to use an int. I don't think I'll change this anytime soon to anything other than U32. So, but that's something that we should be aware of. That can happen. So going back to the game entity, I can now here have this default value of invalid ID. And this one is IsActive. I just use to add or remove this entity from the engine. I'm actually not sure if we really need to do this, but I'll just leave it there for now. So the only thing that I want to do here differently is just to check if active is true. That means that this entity should be loaded in the engine, and otherwise it should be removed from the engine. These are the functions that I'll be importing from the DLL. And then we can call them like this in the editor code. But first, before we do this, I have to finish this DLL. So going back here, I can see that here, where we were adding this to the entity. This function will get some kind of description from this game entity. It's basically what components it contains, right? So in this CPP file, we have to have some kind of entity description. Or rather a descriptor, which is a pointer to entity description. And again, I would like to have an anonymous namespace to encapsulate all of this. And down here, I'll put the definition of this game entity descriptor, which again is just a list of its components. And the only type of components that we have now is just a transform component. And again, I have to define this as well as a structure. So the reason that I'm doing this again, like you might think, okay, you already did something like this before here in this transform component. But you might also notice that rotation here has 4 components, and in this DLL it has 3. That's because the data coming in from the editor, which is pointed to by this descriptor, has another format that we have to convert here before we can use it in the engine. So that's why I need to redefine these kind of data structures. And therefore, I also need a method to convert this to a initialization info structure. Because remember, we have here this. And what we have to do is basically we receive this from the editor, these 3 fields or 3 arrays of floating point values. And we have to convert this to a format that is accepted by the engine, which is this. And luckily, the only difference is that we have to convert this rotation. We have Euler angles from the editor that is contained in this rotation with 3 components. And we have to convert this to quaternion representation of a rotation. So that I can do in a method. And for this conversion, I'm going to use the DirectX math library. For the position and scale, we can just copy literally what we receive to this info. So this memcopy copies from this address to the array in the info structure. And it's this number of bytes that it will copy from this one to this one. And we can do the same for scale. Now, before we can copy the rotation, we have to convert it to the quaternion representation. Here we have this function, with this monstrous name from the DirectX math library that converts the Euler angle representation of a rotation to its quaternion representation. And it puts the result here. This is, by the way, why I'm not using this camel case or whatever it's called naming conventions, because at some point it's just difficult to read. I mean, if you look at to me, this is much more readable than this, right? Especially if you have functions that are close to each other in their name. Like suppose you have this function and you have another function that is this, and they are in some part of code that contains a lot of those kind of functions, and it's really difficult to make out this one from the other one, right? Well, you have here, if we use this notation, then I think it's much easier to differentiate between these two and these two. So yeah, I really don't like this. And that's why I use in the C++ part of the code, I'll use the convention that I'm using here to write this code. Okay, let's get back to our method. And now the only thing I have to do is to put this back to an array of floating point values. This is basically the same as what we have here. It's just 4 floating point values in an array. And this function just writes the value of this quaternion from the SIMD registers or SIMD memory to this stack memory or memory array on the stack. And then we can use this to copy to the quaternion in the information for transform. Although this is 4 values, 4 floating point values, like this, it's not an array. So the way I want to copy these 4 values to an array is just to give the address of the first variable in this struct, and then from there it will copy 4 floating point values to the rotation array in the info. And then we are done, and then we can just return this info structure. And then I can go ahead and try and implement this create game entity. In order to be able to use this function, we need an entity info structure that I filled in here. So basically, I converted this information from game entity descriptor that we receive from the editor to an entity information structure, and then use that to call create game entity. And if that happens, we can just get its ID and return it back to the editor. Then I have to do one more, which is for removal of entities. Now I have to create a game entity from, well, not a game entity, but one of these API entity classes that is actually just an ID. I have to make one of these in order to be able to call the remove entity, because it, of course, wants one of these entity class instances. For that, I'm going to write a method. So this basically puts this ID in an entity ID and puts that in an entity that we can pass to this remove game entity. And that's it. That's all I have to do now for the DLL. Of course, we have to import those functions in the editor, and I can do that now. Here, I'll add a new folder for our DLL imports. I'll call that a DLL wrapper. And here, I'll add a class. We need this name to import from this DLL. Okay, so I'm importing the function that we wrote in this DLL file, in the DLL create game entity, and we have to define the equivalent of this game entity descriptor in our C# code as well. So here I'm going to have another namespace. Now I have here this game entity descriptor, and I'll have to tell the .NET interop services that anything that is in here should be laid out in memory sequentially, so we can access it in order in C++. The way we can do that is by having an attribute. And the same as we did here in the C++, we have to define a transform component structure in C# as well. So again, I'm going to use this structure layout sequential, and then define a class that's the transform component. And then I'll include an instance of this in game entity descriptor. And all we have to do now is to define a public function that converts our entity, as we defined here in the game entity. That would convert this, actually, an instance of an entity, to an entity descriptor. So it would convert a game entity to game entity descriptor. So the reason that we just don't use a game entity directly is, of course, that first, we don't need everything in the game entity. For example, this is enabled, or a name, or a parent scene. Well, we don't have anything for that in the C++ code, and we are not going to use that, right? And the second is that all this data is not laid out sequentially per se in the memory, so we can't really point to any of it. Like this component list and those kind of things. We just can't access it like it is now from the engine DLL. So we have to convert it to something that we can work with in C++. And the way I'm going to do it is this. Here I have to fill in different kind of components that we will have in the game entity descriptor, but I don't have anything in game entity to get any kind of components that we might have. So I have to go here and define functions that I could call to get a certain kind of component from this list. I can use this function to get a component of a certain kind. For example, I can now go back here. I can call getComponent. And this would give me a component of this type, and then I have to actually cast that to the transform. So this component will be of type transform. What I also can do is to write another generic function that would do this for me instead of me just casting it every time. So now with this method, I can just write the same as I did, but it's shorter. And now I can get everything that's in this transform component and copy it over to this transform structure for use with the DLL function. So here I extracted anything that I need from the entity in order to be able to create a game entity in the engine. So for now, because we only have a transform component, I get the information from the transform component. And later on, we'll have other kinds of components as well. And then I'll use this function to get those types of components and get information from them as well. And fill that in the descriptor and call the DLL function to actually create a game entity for us in the engine. Next, I have to do the same for remove game entity, except that's actually a bit simpler. Here, I just get the entity ID that I remembered in the game entity and call the DLL function with that ID, and it will remove the entity with that ID from the engine. The only thing I have to do now in order to use this is to set this IsActive to true or to false whenever I add a game entity in a scene or remove it from a scene. And that happens in the scene class. If we go here in scene, and here in add game entity and remove game entity, I have to make sure that the game entity is set to active or inactive. So I'm going to make a couple of changes in the add game entity and remove game entity, because here in the undo redo action, I'm inserting these entities back to the list of entities, but I'm not setting the IsActive or inactive. And I can better handle that in these functions instead of modifying the list directly here. So here in add entity, I'll have an index, because instead of this insert, I just want to call add entity with an index. So I'll have an optional index. And then because I am adding an entity, I'll set it to active. And that only happens when the scene is active, because only active scenes are loaded in the engine, and the inactive scenes are not loaded in the engine. And I'm not sure if I'm ever going to allow an inactive scene to be modified. Like when a scene is inactive, then we shouldn't be able to add or remove game entities from it. So yeah, I could just do this, but to be more flexible, I'm just using the IsActive property from the scene itself. And then if this index is -1, that means that I just need to add an entity to the list. It's a new entity. And otherwise, it's probably from an undo redo action. And then I'll use the insert function instead of the add function. And in remove entity, I just deactivate the entity. And then modify these undo redo actions. And one more thing I should do is also, whenever we load the project, we should set the entities accordingly. So if this is a scene that is active, then we should set all these entities to active so they can load into engine. That's everything that we need to do to be able to use this new DLL. So now I can set breakpoints here. In our game entity in IsActive, I can put breakpoints here. So yeah, we have an entity, and I'm not sure if I have the native debug ability on. Here, let me see. Debug. Yeah, it's checked out. Let me turn that on first. So enable native code debugging allows me to go from C# to the C++ code and the other way around. So now I'll be able to go in this function and then see that everything is copied over correctly. Okay, now we are in our C++ function. And this pointer looks okay. So we have all zeros here. And then we just copy everything over. And now if you look at this transform info, you can see that this rotation has a fourth component, which is 1. And that's because a quaternion that represents a rotation is always normalized. That means its length is 1. And, well, when all other 3 components are 0, then the fourth component should be 1. So that makes sense. And then we go here and, well, I know that this is going to be fine because we just tested it, right? We tested that everything, addition and removal of entities, that was okay. So we can now go back. New entity should have an ID of 0 because that's the first entity that we added. Yeah, that's 0. Going back now, this ID is 0 and it's valid and we are fine. We have one more entity, there's 1 and then 2, 3, 4. And yeah, we have 5 entities, and that's number 0, 1, 2, 3, and 4. Now, if I would remove one of them, let's say this is 0, 1, 2, so the entity with the index with ID 2, if I remove that, then we can check if that works. So this ID should be 2. That's correct. And, well, I don't have really to check this, but let's do it anyway. This seems to be all okay. This index is 2. And I think we are fine. Now the thing is that now we removed one entity and I could undo that action and it should add that entity back to the engine. So it should reload basically. Let's see if that happens. Control Z. And yes, we are trying to create a new entity in the engine. So that works nice. So the entity that we removed had the ID 2, right? But now we are going to add a new entity. And if we see what ID that one will get, its ID is 5. So it's the same entity, basically, but it's put somewhere else in the array because we have this system of free IDs and generations going on here. So the same entity can have different IDs when we remove it and put it back to the list again. Okay, and it's back again. And I can redo that action and then it will be removed. That's good. And here I can add one more and then undo that. Yeah, it seems to be working just fine. So congratulations, we started using our game engine for the first time. It took me quite longer than I had anticipated, but we are done for today. So next time what I want to do is to do actually a beauty pass for our editor. So it will be less ugly than it is now, hopefully. And then, yeah, I think I'll have 1 or 2 videos just doing that, which will be blue episodes basically. So functionality-wise, we won't have any changes for the coming 2 videos, so feel free to skip those. The only thing that will change is the look of the editor. Thank you for watching, and I hope you enjoyed. I hope that you don't think that these videos are boring, because I'm enjoying it a lot making these videos, and I hope to continue working on these videos for a long time until we have a fully functional game engine. It will probably take me a couple of years to reach that point, but in the meanwhile, I hope to get to know a lot of like-minded people that are interested in the same things. And if you have any tips or comments, then you know where to put them, namely in the comments of the videos. And feel free to like and subscribe. That really helps me to grow the channel, so I'd appreciate it a lot if you would consider doing those things. And of course, I have my Patreon page as well. So if you want to have full access to the code of the engine, then consider becoming my patron and get access to the GitHub repository for the code. And there are a lot of other goodies and exclusive rewards for my patrons as well. So feel free to visit the Patreon page. The link is in the description below. And then I'll hope to see you next time.